Okay, let's do the next one. 1, 2, 1, 2. So it is going to be double replacement. Single replacement is only when I have like 1 of something on one side and then 2 of something on the other side, okay? So what could possibly be my product? I could probably have outside, so iron sulfide and sodium chloride. Let's make sure I wrote my subscripts correctly though, because remember, these little subscripts don't carry over. Don't worry about those, okay? I need to make new subscripts. So I'm going to say, all right, iron's charge then, according to this one, is a 3. So iron is a 3 plus. And sulfur usually is a 2 minus. I crisscross and I get FeS3. So this would be my new compound, and then NaCl 1, 1, so crisscross, and I'm good to go there. Okay, the next one, I have to predict whether or not they're going to be an actual reaction or not, looking at my solubility rule. Let's do the easy one first, NaCl. I know that Na is group 1. Group 1, according to our chart, is always aqueous, because remember, back to our flow chart, all group 1 and the canned ones are soluble, so no precipitate. But then we have the iron one and the sulfide. So what was the rule about sulfides? Remember, it was one of the ones with Senor, what was his name? Oh yeah, Senor Cava. So I'm gonna come over here and I'm gonna say sulfides. If I have Senor Cava or group 1, then it is soluble, but it doesn't meet any of those criteria. So all other ones then must be insoluble. So I do have a precipitate in this case. So remember to keep all my solids for net ionic. So over here I'm going to just write the ionic one. That is a solid. Then I don't have a charge because this is a solid compound, so no charge. Then I come over here and I say, all right, which ions made it possible for me to have this one? I'm kind of skipping ahead. Remember, I'm not doing the whole total one. I could, but I'm not. I'm just going to look with my eyes. And I'm going to say, all right, so this one had something to do with it, and also this one had something to do with it. So bring him down. I'm going to say iron. And what was the charge? It was 3, according to this one. It is aqueous because of that. And then I'm going to say, okay, and this one, sulfide, is what is the charge? It is 2 minus always, and it is aqueous. Now, I need to make sure that this is balanced, right? So I'm going to say equals, well, this one has no charge, and that one is plus 3 and minus 2. Uh-oh, I ended up having 1. I need to balance that so that it's either a 0 or this side and this side is equal to each other. So let's work on balancing them. So what am I going to say? I'm going to say, okay, in order for me to balance this out, I need to make sure that this one and this one is going to 0 out themselves. So let's do that. If I have 2 on this side and 3 on this side, then I am going to end up making plus 6 and minus 6. Well, they seem to equal out to 0, so that's great. But remember, what I do to this side, I also must do to that side. So I need to double check. I have 2 iron, 2 iron, 3 sulfur, 3 sulfur. So that's one way. Another way that you could have balanced it was, you know that you had these down here, and then here you had this one. So you're going to say, okay, I have 2 of these, but I only have 1 of that. So I'm going to go ahead and put a 2 there. I have 3 of these, but only 1 of that. So I'm going to go ahead and put it there. So either way, what I'm saying is that you need to balance it so that the charges are neutral. But that's the reason why I look at, how many of these I have.